Alright, welcome back to Meteorology 101. In this video I'm going to jump into the surface chart, and then we're going to go into the models. We're going to look at this low pressure system that's over the west, and let me pull that up real quick, and then we're going to basically do a surface analysis, try to see what's going on, and then give you our opinion of what's going to happen. And we got the SPC, what they're warning in the southeast right now. We have this high pressure system in the southeast, low pressure system over the west, right near the four corners. It's a pretty intense low pressure system. You can see the pressure gradient is pretty tight. So I'm going to put the isotherms on here. Alright, so what we're looking for in this low pressure system, the models were showing that this low pressure system was going to actually break off. We have an inverted trough off this low. We have cold air advection behind that low. And then we have warm air advection ahead of that low. So we need to look at where this warm front, how far east this thing's extending. We got all this warm moist air being pumped off the Gulf from this high pressure system. That's been just pushing that warm moist air to the north for a few days now. So now that we have this frontal boundary coming through, we need to see where our lift is and where our significant weather is going to be. Now, what we look for is, in the wintertime, we got the jet stream. So that's probably going to be something like this. We'll have to pull that up. The north-south temperature gradient is what shows causes the jet stream. So, but if we have a cold front to the back, we know we got our jet stream behind that cold front. For warm fronts to ahead of that low, then the jet stream is going to stay north of that warm front. So we do got some ridging going on in this area. Warm air advection causes higher heights because that causes ridging. We got troughing in the to the west of that. So how fast this low pressure system is moving is going to mean something. How fast that warm front's moving to the north is going to mean something. And what's the interaction in the southeast? So that's what we're looking for. Let's go ahead and pull the station plots up. See where our winds are. Alright, so what we can see here is a little bit lower ceilings through this area, all the way through here, all the way up there through the blue, the reds, IFR, marginal VFR conditions, and in the south. So what we had in the Ohio Valley region is fog. We got plenty of moisture. The models were showing us the last couple of days a low pressure system is going to form up right here. That's going to break off. So this is going to become its own separate low. So we would basically have to have a ridge pushing down into that to separate them two. And then, which we know we got ridging going on. And then this warm front, we're going to have to place that warm front. So if we look at the wind directions out of the south, then they start switching out of the north. We know we got a boundary right there. So this is our warm front right through here. Let me clear that out. Okay, right between that wind shift. Something like this. So we know we got warm air advection. If we look at where these isotherms are crossing the isobars, we've got pretty strong warm air advection in this area. Weak warm air advection in that area. So I think we have a severe thunderstorm over here at this time. So as all this warm moist air is pushing to the north, we're looking for that boundary to start interacting with this. And then, like I said, the SPC has a pretty elongated area for possible severe weather, or mainly just thunderstorms. And then their real outlook for severe weather is pretty much Tennessee, Alabama, Mississippi. But if you look at, we got the moisture down here, dew points of 72, 64, 65. So you're looking at 65 or better is where you want to look at for severe weather. We're down to 58 here, 56 here. So right along this area is where, if we have any supercells pop up, it's going to be right in that tri-state area. So I'd narrow it down right there. And then, now, that's not to say we're not going to get strong winds through here. As this low pressure system pushes to the east, that we're not going to get winds, or that low pressure forms up right here. That's not going to cause any significant weather. I would look for heavy rain, maybe some flooding, flash flood warnings, stuff like that up in that area. So anything north of Mississippi, Alabama, then along the edge of that inverted trough, I would look for pretty much what you're going to look for is right here in that trough. Anywhere ahead of that trough right through there, I would look for any kind of significant weather in that area. For thunderstorms, rain, heavy winds, if anything goes severe on that, it's going to be from the winds, I would think. So we'll keep an eye on that. Now, we don't want to see the intensity of this low pressure system. We can go up into the upper levels, look at 850, see if that's a closed off, upper level front. But let's go ahead and jump into the models. We'll pull a couple soundings for the south too, see what kind of stability we have. See what our stability indices show us on those soundings, and we can go from there also. Alright, so this is for Saturday 06Z. It's about 1 o'clock in the morning. We're pretty close to that right now. And then we look at this cape. So right in that area we're looking for, but let's see what we got for readings right there first. Shut this off. So right now 416 joules. Drop it to the south, 100, 200, 300. Now this is only 09Z, Saturday, 4 a.m. Eastern time. So for us to get any significant cape, let's see, 200s, 300s, 600. It's all pushing to the south. 800, 1,000. We need to still go. I don't see any significant cape going through on this model at all. This is a GFS. So we'd have to pull up maybe an HRRR, get into that area, and see if we have anything significant that's going to show us anything. The best thing we can look at is real-time data. We pull up a sounding. Now we have Birmingham sounding up. This is for 0Z. And we do have a big area of positive cape there, and that is 960 joules. So we're pushing almost to 1,000. So we do have the energy in Birmingham. 500 millibar winds. Here's the positive tilted trough that everybody's talking about. The support for that low pressure system. Now this is Saturday 18Z. So that's telling us right there we're still in the west. Let's go start from the beginning here. Positive tilted trough. Right around the four corners, we're pushing to the east. Where are we getting to? We're getting, the high level winds, the head of that trough pushing through, and this is already well into Sunday. So we need this to push through on Saturday if we're going to say that trough's going to have any interaction with that moisture in the southeast and cause us some major tornadoes, long tracking tornadoes. And that doesn't look like that's happening. Here's Saturday 18Z, 21/0Z at 7 p.m. Be 6 p.m. Central Time. Then here's midnight. So our positive tilted trough is still well to the west. So your significant weather is going to be at and ahead of that trough, but we still have ridging over Mississippi, Tennessee, Alabama area. There's a little bit of slight ridging there. Higher winds, but we're at 500 millibars, so that's not a low-level jet. We need to look at 850 millibars to go see if we have a low-level jet. So right there is 06Z on Sunday. That's midnight Central Time. So let's back it up. There's our low-level jet, Alabama, Mississippi, and this is 21Z Saturday. But like I said, that trough is still well to the west. So we got an area for supercells to form, but that positive tilted trough isn't going to. That's not going to do anything for us. I mean, it's supporting that low pressure system. It is doing its job, but it's not. This isn't going to be like some major tornado outbreak that's just going to be long tracking tornadoes like we've seen in Mayfield. We're not going to see a tornado tracking like that. That was a very rare system, and that's not happening here. this isn't going to be, this trough breaks off into its own low and ejects a low out of the 500 millibar. So right now we're at 850, but let's go to the 500 and we'll show you. We'll go through Saturday right here, deep trough, Sunday, and then that's where it ends into right there, Saturday again, into Sunday morning, into Monday morning. That's when you're pushing, that trough's pushing through, but that trough never does become cut off and ejects a low out of it, not like what happened with the Mayfield tornado. So that positive tilted trough is doing its job. All that snowfall in the over in this Nebraska, the central U.S., that's all going to be caused by this trough and that low pressure system. So, and as that low pressure system pushes to the east, yeah, it's going to cause some significant weather, but we're not going to get like major tornado outbreaks, especially up to the north. So let me get all the way back. This goes all the way out to January 15th, 16th, 17th, and then back to January 1st. Okay, so this is pretty much where we are now. That major short wave supporting the upper support in the upper levels for that low pressure system on the surface. All right, so we've seen our low pressure system. Let me throw the computer fronts on here real quick to see what happens. I don't expect much out of that. This is a pretty chaotic system, so probably going to get fronts all over the place. They don't do a very good job with placing fronts on these things. So, like I said, cold front, warm front. I mean, if we had a low pressure system down here, that's wrong. We get this low. I mean, you know, we know all that's warm air advection. So anything ahead of that low is warm air advection with the winds out of the south. Anywhere you see winds out of the south, that's pushing warm air to the north. So that's warm air advection. So let's go to let's pull some other charts here and see what we got. Let's pull in telecast. Now we can see there's our overall look right now. Here's all of our warm air advection off that low pressure system. Back wrap around moisture on that low. Snowfall all the way up to Nebraska, Colorado, and even maybe some troughing from that low pressure system pushing down into New Mexico and Arizona, causes snow in the higher elevations there. So this is an overall look at the U.S. radar. Let's go back over and the local radar, and like I said, in North Carolina, we just had a severe warning here, and that expired. We'll go back a few shots, and there's our severe storms right south of Southern Plains. So we can see that right back over here. Any positive vorticity advections will be the south. Right there matches up with our severe storm we had in North Carolina. This matches up with the low pressure system that's over near the Four Corners, and then all that warm air advection. And there's some ridging at 500 millibars that is higher heights that's associated with all that warm moist air being pushed off the Gulf. So downward flow, we're down off the ridge. So anticyclonic rotation right there, and negative vorticity. So that's going to suppress a lot of these severe thunderstorms. So that's another reason we're not going to have some big major tornado outbreak and tracking from that. So that low pressure system is going to form over, like more over to the east over Ohio Valley. It breaks off of that low because we had that low troughing over with that inverted trough. Then that low breaks off, forms its own low, and then moves to the east. Now that's going to give us our lift with the moisture that we have over the Ohio Valley. So I would say, you know, all the way through here, significant rainfall. We have to see what kind of moistures we have in the upper levels to see what type of precipitable water we might have with that system. So we can get some heavy rainfall, some flooding, stuff like that. So let me get to another chart. Alright, so this is the Theta E advection. It's a Kelvin temperature advection chart that shows if there's going to be anywhere for significant weather. I mean, pretty much this whole area. Pretty much this whole area is an area for significant weather, but not necessarily tornadoes. So stronger lift here, stronger here, stronger there. So you see we don't have any real significant stuff going on in Mississippi, Alabama right now. So there's definitely going to be, as this low pressure system pushes to the east, then there's definitely going to be, you know, some lift with this warm air, and as that warm front pushes up, and then this low pressure system that forms up over Ohio, if, you know, that starts creating some cold air advection behind that, pushing up all that warm moist air, you're definitely going to get some significant weather right along that front. Now, we just got to keep an eye on how that low pressure develops, and I would definitely say there is going to be significant rainfall in this whole area. So we're going to pull up a critical wind chart area for critical winds. Let's see what we got for any hatched areas. Alright, so as we can see on this one, definitely got an area, Colorado, Kansas, Nebraska. So that's associated with that low pressure system. So significant winds in those areas, which we know we're getting significant winds in Boulder and Superior, Colorado, with those fires. You know, they were getting some pretty strong winds off that low pressure system that was, you know, just feeding those fires and causing a lot of havoc over there. So we do have that little area right through here, right there, and that's actually in a pretty good position for that tri-state area. So that's where I was kind of looking at with any supercell development, instability, Birmingham, pulling those soundings and looking at, you know, any soundings that were available in that area, real soundings, not just extrapolated data from the satellite or from the models, but actual real balloon releases that were showing us real data. So we had the Cape of about 1,000, so that was, you know, pretty significant for giving us some supercells in that area. Now up in Tennessee, we're pretty close to that where that low pressure system is going to form, or that inverted trough. So I would look for more heavy rain in this area. So with the critical winds, possibly some severe thunderstorms in Tennessee. I mean, they're probably going to have some isolated thunderstorms all the way through, severe thunderstorms all the way through this area. Right along where that low pressure is going to form up, but I'm not looking for any significant tornadoes or anything. If anything goes severe, I think we're going to have a lot of wind damage from that low pressure system, and I think we're going to have some significant rainfall. But if you're looking for any tornadoes, supercells, anything, I think it right around the tri-state area, mostly in northern Alabama, Mississippi, I think is where you're going to have most of your tornadoes. You're not going to have some long tracking tornado all the way across the U.S., anything like that. But I think we're going to have our supercells in the south. Let's see what else we got here. Let's go up to the 500 millibar. Let me run a 500 millibar chart real quick and see what we got for moisture right there around that low, close low, troughing, ridging in the central U.S., and then just a barotropic system all the way through on the troughing off the east coast. So we're going to pull up a 300 millibar chart. We're going to look at our jet stream. I'm going to put the shading up first. Alright, so we still got that low pressure system. Almost closed up to 300 millibar, which is pretty impressive. Let's go to get rid of this real quick. We'll throw up the get the isotherms on there. We're going to see some thermal advection, but we can see then we got ridging in this area in the upper levels. Ridging. So we're still suppressing that. Got a jet max moving out of that ridge. So that ridge should weaken, allow this low pressure system push to the east. We were, like I said, we were looking for maybe a low pressure system to form up over the Ohio Valley. We had to jump back into the models and look at that surface pressure and see what happens there. So we do have a little bit of wind shifting right here. So a little bit of troughing in that area. So anything out ahead of this trough, we were looking at lift. So we did have that area positive vorticity advection over North Carolina. So that kind of matches up right with that troughing in that area. We still have significant moisture at all of these stations. So we're still got plenty of moisture there. Plenty of moisture over here. So when this low pressure system pushes to the east, we got plenty of moisture to pick up. And then, like I said, that surface high is still pumping moisture in the lower levels. Alright, so our jet stream, there's a long wave trough, ridging. So our trough pushes to south. So anywhere along south of this trough, there's your ridge, troughing. So trough, I would think you were not going to have really any major severe weather. You're going to have to be down in this area. Right over that jet max, out of that jet max, through the jet, that's where you're going to have your upper level support for that system. So I'm sticking with the tri-state area. Going to be for the most significant weather for tornadoes. We're going to have a lot of, like I said, storms, flooding, downpour, straight line winds, possible severe thunderstorms, but tornadoes are going to stay to the south. This low pressure system will take a while. It don't come back over here till probably about Sunday. I think we've seen Sunday into Monday. So that's when that low pressure system gets over here. Now that's going to be a whole different story, because being a, you know, more than 2 days out, the models they're just falling apart anyway. I mean, they're not handling any of this stuff very good lately. So we'll keep an eye on that system in the next few days. But right now we're just talking about tomorrow. Alright, let's go to back to the models. Get the times where you can see them. When we push this through, like I said, it takes a little while for that low pressure system to come across. And then we had a low pressure system kind of break off, and it looks like it kind of breaks off right there. Let's go get your tool up here, go to right there's a low, right there's a low. And this is pushing into Saturday 21Z, and then that pressure system pushing through to the east. Let's see. Let me get a bigger look at this thing. All right, there we go. So we see the low pressure system over the Four Corners. That's pushing to the east. The line looks like it's forming up. Pretty accurate for the precipitation all the way up into the Ohio Valley. And it kind of looks like a low pressure system forms up there. It looks like it breaks off closed isobars. Let me get my pin up here. Pushing through, this is all the way through downward overnight Saturday into Sunday. Pushing through Tennessee all the way to hits the mountain range and just dies out, and then looks like a pretty strong cell pops up over Georgia. And then stretches up into the Carolinas once it gets on the other side of the mountain range. And then we got a pretty significant low pressure system. Looks like it pops up right there. Let me go back. See where that comes from. Looks like the low pressure system did form up over Ohio. See a few closed isobars right there. Right in that area. Clear this out. Right there. So right through there. So then it looks like this kind of forms a cold front. And then pushes to the east. And then that's some troughing right through there. Let me get this up. So we got that trough right through there. Looks like a frontal system pushing through once it gets on the lee side of the mountains, and then pushes up through and then becomes something over the east coast. So this is through, let's see what date this is. Monday, Sunday night into Monday. Looks like the east coast getting hit pretty hard with some heavy rain. So possibly severe weather there. We'll have to see what the SPC puts out. I didn't plan on going this far out. I was just looking at for Saturday. So let's keep an eye on that system too, as that low pressure forms, creates a cold front, and high pressure pushing in behind that, ridging all the way down into Texas, and then that system pushing off the east coast and high pressure dominating the east coast after that, the whole eastern United States, and clearing the weather out. So alright, that's pretty much it for now. I'm gonna so we'll keep an eye on that system, and then like I said, this precip here on the GFS, it's holding pretty accurate for the rainfall. Some heavy rain pushing through Tennessee, Kentucky, up into the Ohio Valley. Windy conditions for sure, and then look for the supercells down in the tri-state area, mostly northern Alabama and Mississippi. So I'm going to go ahead and end the video. I want to say thanks for watching. Visit my website at meteorology101.com and get your head in the clouds.